this graph, we're going to have a velocity versus time and acceleration versus time graph overlaid on top of one another. I will show you how to make this graph and also how to graph the tangent line at various points along a curve. From our workspace, to take the derivative, click Analysis, Take Derivative, select your x and y variables, click Take Derivative, and then rename your column. Let's next run a quick check to make sure that these are looking the way that we expect. So we run a velocity versus time graph and get as we would expect. And we run a separate acceleration versus time graph and get about what we would expect. We can run these independently, like so, or we can do what's called a dual y-axis graph. In this case, data may look a little better if we have the traces set to line. To enter a second y-axis, go to Axis plus new right y. We could also stack the plots on top of one another. In this case, I like the superposition. Now we can rename our axes and our title accordingly to get something that looks like this. Here I've graphed the tangent line when time equals 16 seconds. So to do this, I created a new column. You need to have a deeper understanding of derivatives and the equation of a line. I've used the point slope form here and rearranged to solve for y. If we look at the point closest to 16 in our grid, 16.10, we find that the derivative is 0.21. We will use this as our m value. We will use 16.1 as our x1 and negative 1.9 as our x2. I then created a column by using Data Tools, Formula X, and I entered the equation 0.21 times x minus 16.1 plus negative 1.9. After that column was created, I added it to my plot by selecting, instead of Make a New Plot tab, the velocity versus time tangent line graph that I had made. And that's it. So in this tutorial, we've covered how to graph the derivative of a function and how to graph the tangent line at a specific point. Happy plotting.